Hello, and thank you for watching this video on the equations of lines using the point slope form. What I'm going to go over the examples here. Examples I'm going to go over in this video is how to use the point slope formula to write the equation of a line in the slope intercept form. Now, our point slope form is the format where we have our equation written as y minus y1 is equal to m times x minus x1, and the x minus x1 is in the parentheses, as you see right there. We use this system whenever we want to write the linear equation and we're given a slope and a point that is on the line, a solution to the equation y equals mx plus b. So I like this formula here more than using this substitution method, because again this requires just plugging it in and simplifying using just simple inverse algebraic expressions, so a distribution and an inverse operation. So let's look at how we use this example. So on our first example, to use the formula y minus y1 is equal to m times x minus x1, we have to be given a point, which we're given a point on the line, and we have to also be provided a slope. So let's start with the point of the line. We know that the y1 and the x1 is going to correspond to the x and the y value of our point. Okay, so those two numbers are going to come from our ordered pair, and we're going to replace the y1 with the number -1, and we're going to replace the x1 with the number of -4. Now the slope in this particular example, they don't tell us that m is equal to a specific number. They tell us that m is going to be equal to a line parallel to this. We're going to get the slope by identifying what the slope is here, and then simply using the same number, because I want this new line here to be parallel to this existing line up there. Well, since the slope here is the number 2, that's the number we're going to use for m in our example. So I'm going to start by plugging in, and I'm going to get y, and I'm going to subtract the y value, which is -1. I'm going to get m, which is the number 2, and in parentheses write x minus the x1 value, which is going to be the number -4. So x minus -4. Now to simplify this, I first notice again that I'm subtracting a negative, so I want to simplify that. Subtracting a negative is the equivalency of adding a positive. So anytime I'm subtracting a negative, I want to write that as simply plus. And then we follow the following two steps. We distribute, again, which means that we're going to multiply. So in this parentheses, we're going to distribute this 2 and multiply those two values with 2. And multiplying x with 2 is simply 2x. But multiplying 4 with 2 is going to equal to 8. And our second step is going to be to either add or subtract, or in very simple terms, move the y1 number to the right side of our equation. And whenever here's the left and right side of the equation, by moving this to the right side of the equation is going to make it the opposite. Now line this up again with the numbers over numbers, and now with the x term, because this one has an x and this one doesn't, so they cannot be combined. So make sure you line it up with the last number there, and we're going to end up with y is equal to 2x plus 7. So that would be the equation of a line that is parallel to this, that has the same slope as that, as you see right there, and that goes through that point right there. Now to check that our line actually goes through that point, let me make this smaller, move this out of the way. To check that this equation here goes through that point right there, I just simply have to substitute in for our x value right there. So I'm going to substitute in the x with -4, multiply with 2, and add 7, and see that the y value is also equal to -1. So let's see, let's simplify this. Well, this is equal to -8, and -8 plus 7, green, -8 plus 7 is equal to -1. And yes, look, it matches to that number there. So plugging in the x value tells us that y is equal to -1, which is matching again the coordinate pair. So I know that this equation is going to be the correct equation that is parallel and goes through that point there. So example number 2, same type of situation. We want to plug in again into the following, into our point slope form. So the point comes from the ordered pair, and for y1 we plug in the y value. For x1 we plug in the x value, and for m we're going to plug in the slope that will be perpendicular to this equation right there. Well, the slope of this line is equal to 3/4. In order to be perpendicular, we have to satisfy two conditions. The first condition is that they have to be opposite, and the second condition is that they have to be reciprocals of each other. So the number that we're going to use for this m here has to be the opposite of this number, which is a negative value, and it has to be the reciprocal of that number, which simply means to flip it. So flipping that number puts the 4 on the top and 3 on the bottom. So this will give me a line that's perpendicular to that. So using this number as a slope will give me a line that will be perpendicular to this line right there. So now that I have everything to plug in, I start plugging in. So I write y minus my y1 value, which is -3, is equal to our m, which is -4/3, times x minus our x value, which is x1 value, which is +3. Now, just like in the previous example, since I'm subtracting, as you see right here, I'm subtracting a negative value. That is the equivalency of adding a +3. So I'm just simply going to make this into +3. So y +3 instead of y minus -3. Now I don't have to worry about this because here I'm not subtracting -4/3. I have -4/3, and I'm going to distribute that into the -3, into the parentheses of x minus 3. So y plus 3 is equal to -4/3, x, and again that's that, and multiplying again, this is multiplication, do not forget to multiply that second number. That's going to equal to +4. Subtracting the 3 from both sides, or in very simple terms, moving the 3 to the other side, making it minus, we get that y is equal to -4/3x plus 1. And I can check if my work is correct by checking that these slopes are opposite reciprocals, which they are. Notice that the number is the opposite and flipped. But to check this part, that the line goes through this point, I simply, getting my equation, I replace the x value with the x value of 3. So I'm going to plug in 3. -4/3 times 3 is equal to -4. And -4 plus this 1 right here is equal to -3. And you see, look, the value of y is equal to 3. -3, I'm sorry, I forgot the negative sign. -3, which matches to that point there. So plugging in x, I get the value of y. So in our next example, again, y minus y1 is equal to m times x minus x1. We're going to do a little bit more of the same stuff. Again, more examples of the same stuff. So I'm going to do this a little bit more quicker. We're going to plug in 7 for the y. For m, we're going to use the same number since we wanted to be parallel. So -5/2 and x minus -6. I distribute. And we're going to get -15, and I'm going to add 7. So y is equal to -5/2 x minus 8. So that's the equation of our line. Number 4, a little bit more of the same stuff. So I'm going to go through this example real quickly. Sorry, that should be the next one. So we're going to replace the y with 3. So y minus 3 is equal to, I'm going to leave that one, m, well it was, but no, m has to be perpendicular. So since this slope is negative, to be perpendicular it would have to be the opposite, which is positive, and the number has to be flipped. Well, to flip 2, which is equivalent to 2/1, that would be 1/2. So that's going to be 1/2. And x minus the x value, which is 4. So y minus 3, I distribute, we end up with 1/2 x minus 2. I move the 3 to the other side, making it positive, and y is equal to 1/2 x plus 1. And there's your the equation of your line. So now for the next one, this one again is still going to use, we're going to again use this formula right here, but this is going to require us to do one additional step, because you're going to notice now that our equation here, this equation here, is not written in the slope-intercept form. So I know what numbers to plug in for x1 and what number I'm going to plug in for the y1. Again, that's going to be 3 and -1 from the coordinate. But for the slope, this is going to require me to first rewrite this equation in the slope-intercept form, because the number 1 is not the slope. This is not, again, not the slope, because it is not written in slope-intercept form. So if you saw the previous video on how to write the equation from the standard form to the slope-intercept form, then you'll be familiar again with the steps that are required to rewrite this to identify what the slope of the line are, which has to be parallel. So I start by moving the x to the opposite side. So this is positive 1x becomes negative 1x on the right side. We bring everything down, so negative 3y is brought down, the negative 1x is brought down, and the positive 9 is brought down. We then divide everything by the number in front of the y, the number we're multiplying with the y, the coefficient of the y, which is negative 3, and we get that y is equal to positive 1/3 x plus negative 3, or just simply minus 3. Now from here, the only thing that we're interested in is what the slope of our line. Since we want this new line right here to be parallel to this existing line down here, the slopes have to be the same. So the value that I'm going to use for m is also going to be the number 1/3. So now I can start plugging in and substituting in these three numbers. I get y plus 1 is equal to 1/3 times x minus 3. And again, this becomes a plus 1 since I'm subtracting a negative 1. Subtracting a negative 1 is the equivalency of adding 1. So this would be y minus negative 1. And again, this subtraction of negative 1 is the same thing as writing plus 1. So y plus 1 distributing is going to be 1/3 x negative 1, and moving the x to the other y, the 1 to the other side, isolates the y and is going to give us 1/3 times x minus 2. So that's the equation of our line that is parallel to this and that goes through that point there. Now again, you would want to check this, plug in the 3 in there, multiply it with the 1/3, and then subtract, which is equal to 1, and then subtracting the 2, you'll see that it matches and it gives you that y would equal to negative 1 when I do that substitution and replace the 3 into this x right there and simplify this side. I get that y is equal to negative 1, which matches that number. So I know that this equation is correct. So for number 6, same situation. We want to come up, you want to use this formula here, our point slope form. I know I use the formula forms, the same thing, form, to come up with the equation of a new line that goes through these 2 points, which are going to go there, and is going to be perpendicular. So this m has to be perpendicular to whatever the slope is on this line. Now since this is in standard form, the 5 is not the slope. So I have to rewrite this equation into the slope-intercept form to identify what the slope of the line is, which, as I can see, is going to be negative 5/3. So if I move the 5x to the other side, I bring down the 3y. On the right side, I bring down the negative 5x. I bring down the negative 21. So I write that as minus 21 now. And I divide both of these numbers by the 3, by this 3 right here, which technically is, though that's also being divided by 3. I end up that y is going to equal to negative 5 over 3x minus 7. And again, from this equation here, the only thing I'm interested in is this number, this slope right there. Since this number, the slope is equal to negative 5 over 3, in order for my new line, which is this one here, to be perpendicular, I need to, again, satisfy the following two conditions. I need to get the opposite of that number, and I need to get the reciprocal of that number. So the value that I'm going to use for m here is going to be positive 3 over 5. So that's going to make our new line perpendicular to this line right there by using 3 over 5 as our slope. So now plugging in our y1 value, plugging in the slope of 3 over 5, and plugging in negative 5 for x, we get that y minus 1 is equal to 3 over 5 times x plus 5. Now we're going to distribute, which again, you cannot forget to multiply that second number. We end up with y minus 1 is equal to 3 over 5 times x plus 3. Now we're going to add the 1 to both sides, which in simplified terminology simply means we're going to move the this 1 that we're subtracting to the other side, making it plus, meaning that we're going to now add it to the other side. And adding 3 with 1 is equal to 4. So that's the equation of our new line. And again, you might want to check this. Always go back and check that this is accurate. And the way to check this here, let me erase this first. And let me move this over a little bit more. To check if this equation is exactly correct, there's two conditions to satisfy. First is that this new line has to be perpendicular to this. And well, since our slope is negative 5 over 3, 3 over 5 would be perpendicular because they're opposites, negative, positive, and the numbers are flipped. So this condition is satisfied. So we're good with that. We know it's going to be perpendicular. Our second condition is that it has to go through this point there. So to verify if this line goes through this point, again, I'm simply going to replace the x with negative 5 and check that the y value is equal to 1. So y is equal to 3 times 5 times our x value, which we're going to use as negative 5 from our point here. Let me continue using green. And y is going to equal to negative 3. 3/5 times negative 5 is negative 3. Adding that with 4, we get that the value of y is equal to 1. So look, this checks out. So there. We have verified again that this new equation satisfies both conditions. It is both perpendicular to the existing line provided to us, and it goes through that point right there because negative 3 over 1 is a solution to our equation. Now for number 7, we have something like this on your homework. For number 7, we have that a rectangle, that the equation of a line crossing one side of a rectangle in this standard form, in the standard x and y coordinate plane, is this equation here. So what this means here is that this equation here is supposed to represent one of these three sides. And well, since the slope is positive, I'll use this top side right there. It could be this bottom one, but it's irrelevant. So we just know that this equation is supposed to represent a side on the rectangle that is going upward. So let's use this top one right there, okay? And we want to know, out of these four choices here, which of the following equations is a line containing an adjacent side. An adjacent side means that it is going to be next to it. So an example, this orange side would be an example of an adjacent side to this yellow line up there. Or it could be this one up here. This side right here is also an example of an adjacent side to this, again, yellow line right there. Now, since we're looking for the equation to represent that, notice that these lines are going in opposite direction. And they're not just going in any, well, in intersecting direction like this. They're going in the exact opposite direction where these two lines, the yellow and orange line, intersect, and the yellow and blue line intersect at a 90-degree angle. And since one of the definitions about perpendicular lines or intersecting at 90-degree angles is that these two lines are going to be perpendicular. And if two lines are perpendicular, that means that their slope of one line has to be 1, the opposite, and 2, the reciprocal of the other line. So in order to determine which one of these four choices could represent either the orange or the blue line, we're going to look at the slopes of these lines and see which line is the opposite and the reciprocal of 2/3. Well, it's not A, it's not B, it's not D, and you see letter C has the only equation with a slope that is the opposite and the reciprocal of 2/3. So letter D would have to represent the equation of either this side or this orange side here again, or this side right there. So letter C would have to be the correct answer because that's the only one that would be adjacent to that. Now for example number 8, here we have a situation where we want to come up with the equation of a line using again this formula here, and we're provided only 2 points of our line. So the key thing again that's missing here is the slope of the line. Well, since we're provided 2 points on the line, the way we're going to calculate that is by using our slope formula. The same formula anytime we are given 2 points and we want to identify the slope, which is y2 minus y1 divided by x2 minus x1. So -1 minus 7 gets divided by 1 minus -3, which is equal to -8 divided by 4, which is equal to -2. So the number we're going to use for m is going to be +2. So let me write that up here. Let me move this down a little bit. And let me write that for m, we're going to use the number +2. Now for the x and y1, the x1 and the y1, the x1 and the y1, I have two options. I could either use the first set. Okay, I could either use that first set, or I can use the second set. Does not make much of a difference. I just simply have to use again one of the two sets. So I'll use the second set here since it's already there. And now for y1, I will plug in -1. So minus -1 is the same thing as +1. For m, I'm going to plug in -2, not +2, -2. And x minus our x1 value is going to be 1. And again, it doesn't, from this point on, whatever you use for x1 and y1 would not make much of a difference. You should end up with the same answer. So distributing this number, we get that y plus 1 is going to equal to -2x plus 2. And moving the 1 to the other side, we get that y is going to equal to -2x plus 1. And there's the equation of our line. Y is equal to -2x plus 1. So this right here, because we're not given an equation, we're given instead of 2 points, will first require us to identify the slope of the line, and then we just simply plug in just like we've done before. And since we have two coordinates to use from, not just one like we had in the previous examples where we only have one set of x and y's, I can pick any of the two sets to plug in for the x1 and the back and the y1 right here in the front. I would end up with the same thing had I decided to use -3 and 7 in for the x and the y one. And for our final example, another one of the same thing again, we would start by doing the exact same thing. First, using our slope formula. -4 minus 7 divided by 3 minus -6 would give us -11 over 9. So y minus y1 is equal to m times x minus x1. We would plug in again for m that number there from our slope formula. For the y1 and the x1, I would simply have to decide which sets of coordinates to use. Since I used the second set last time, I'm going to use the first set of coordinates this time. So I'm going to use -6 and 7. So y minus 7 is equal to -11 over 9 times x minus -6, so plus 6. So distributing here, and remember, do not forget to multiply that second number. We're going to get -11 over 9 x, and let's see, -11 over 9 times 6 over 1, that's equal to -66 over 9, which can be divided, both numbers can be divided by 3, which is -22 over 3, so -22 over 3. Now moving the 7 to the other side, y is going to equal to, so that's going to add the 7 there, -11 over 9x, and we have -22 over 3, and we're going to add 7 over 1. So we need to have like terms. To end up with like terms, I need to multiply the top and the bottom number on this fraction by 3. So now that the denominators are the same, we're going to end up with -1/3, so -1/3. And there is the equation to our last example. So this one, again, like the previous example, required us to first figure out the slope of the line and then plugging in the corresponding x and y values, and using one of the sets for our y1 and y1, our x1, we can then simplify it and get our final solution. I hope again these examples were helpful, and again, thank you for watching, and I hope you have a great day.